A drone that only follows fixed waypoints is not really autonomous. It is just obedient. Hi, I am Dr. Qamar, and if I had to summarize drone programming in 2026 in one sentence, it would be like this. We are moving from waypoint scripting to behavior-based autonomy. For many people, drone programming still means take off, fly to point A, fly to point B, and then land. That still matters, right? But modern drone development is becoming much richer than that. The official PX4 ecosystem makes this very clear. PX4 describes drone APIs as a way to build high-level drone applications without needing to handle all the low-level flight stack and safety-critical details by yourself. PX4 supports tools like MAVSDK and ROS2, and the docs explicitly recommend learn to operate easier and has more stable APIs, especially for missions, telemetry, camera control, and low bandwidth command/control. But when you want onboard autonomy, things like computer vision, obstacle avoidance, and higher rate onboard communication, PX4 recommends ROS2, using the PX4 ROS2 bridge to expose PX4 internals in real time. That is where drone programming stops being mission upload and becomes real robotics. And the field is still evolving. Recent research in 2025 and 2026 explored that LLM guided UAV visual paths planning and LLM VLM frameworks for UAV visual tasks, showing that natural language and scene aware mission programming are becoming serious research directions, but also highlighting that safety and reliability remain critical challenges. So my practical advice is simple. If you are starting drone programming in 2026 in layers, what you do? First, PX4 for flight control, you can use it. Then you can use MAVSDK for clean mission on logic. Then you can use ROS2 for advanced onboard intelligence. Thank you.